Hello and welcome to another one of these ADD videos. Today we're going to look at the concept of continuity. What must be true for a function to be continuous at some x equals c value? Okay. Well, three things must be true. The function value must be defined. So we must have a closed dot somewhere at x equals c, above or below. The limit must exist. We must zoom into the same place. So if I could go left to right, it must zoom in the same area. And then finally, the function value must zoom into that same y value that you found when you did step 2. So pictorially, what that means is here's some function, doesn't matter what it is. At x equals c, I have a red closed dot. I zoom into the same y value L, and those two things are one and the same, the L value and the red dot. If those three things are met, then you are good to go. X equals c is continuous. So where do we get our candidates? Well, in a rational expression, you just set, you just set the denominator equal to 0. Didn't try to highlight all that. Sorry about that. But so if you set the denominator not equal to 0, what that does is allows you to use your domain rules to find out where rule 1 has been violated. If you remember, rule 1 said that it must be defined, and anything that makes the denominator go to 0 is undefined. So by definition, these guys are already continuous, -2 and 1. So whenever you have a denominator, factor it. Now you will have to do 2 of the 3 steps, because if you fail 1 or 2, you can't do step 3. And since I've already failed step 1 by making the denominator equal to 0, I know I can't do step 3. So I'll do step 2 to find out what type of discontinuity it is. So the chart at the end of this handout is very handy for that. So I'm going to zoom down to show you this chart. And this basically goes through the different scenarios of what happens. So in our scenario, we have an undefined f of c, and you will see that if you take the limit of one of them, it does not exist. You'll get infinity or negative infinity, and they cannot equal, and it will be a vertical asymptote. Okay? This asymptote should also say non-removable discontinuity. Okay? So under asymptote, if you have this chart, write non-removable. That's undefined, came from the denominator, limit did not exist. However, if it was undefined and the limit did exist, okay, they still cannot equal because it's undefined. Then we have one of these open dot scenarios, and that's a removable discontinuity. If you have a piecewise function where it's defined everywhere but one specific value of x, and at that x value they give you another y value. Let me show you what I mean by that. A function that looks something like this. Let me zoom out. So here we have a function, f of x, where it equals this whole thing everywhere but 5. But at 5, our y value is 4. That's one of these scenarios right here. The limit will exist for this. You'll get a numerical value, but it'll be different than 4. Your closed dot is at 4. All right? And then, let's see, we did first 3. If all 3 steps pass, you're going to be continuous. The last one only occurs in piecewise functions, and basically what happens is it can be defined or undefined. Okay, it doesn't matter whether it's a closed dot or an open dot, but the left limit does not equal the right limit. Whenever you do one of those and you get that scenario, that's referred to as a jump discontinuity. All right? And that's pretty much it I will make an example video for each one of these scenarios. Make sure you try to do the examples before you look at them. You can go through, look at the solutions that I make for the example video. Look at the different examples here that are given. Just to touch back on that one example we were looking at, we had -2 and 1, so you'll need to do the 3 steps for both of those. You'll find one of them gave you an infinite value, so it's an asymptote or non-removable discontinuity at -2. But when we tried 1, you get 0 over 0, which is indeterminate. That's misspelled there. And that cancels and gives you a numerical answer, so it's removable. Alright. For piecewise functions, really quick, you test these numbers here on the side. Unless there's a denominator here, you don't need to worry about that side. You just look at what's over here. So in this case, I have to do 3 steps for the number 2. Alright. I hope I've cleared up any confusion that you might have with continuity. Check out the example videos, and most importantly, as always, practice as much as you can. The more you do it, the more second nature it becomes, the less nervous you will be. Thank you, and have a nice day.